What's up, Stone Squads? Welcome back to another episode of Inequalities. So we are at solving multi-steps, very similar to the one we just had previously. We're going to talk about special cases. So the difference between inequalities and an equation, what was it again? Inequalities is a number, a bunch of numbers that can be a solution, versus equation is just equal to, so it's one answer. Alright, so you remember we use less than, greater than, less than, equal to, greater than, equal to. So watch those videos if you have not watched those before. It'll help you when you go on to this video. So there are special cases. So these are my special cases. Okay, just like how we have special case for equations, we also have special cases for inequalities. So there's two of them. So you can get, if you get a value like 0 is less than -5, let's say your variables cancel out, right? That's the only times we have special cases for inequalities. Let's say your variables cancel out, all you're left with are numbers, and your final answer you get like 0 is less than -5. The question you need to ask yourself is it true? Is 0 less than -5? So think of a number line, is 0 less than -5? No, this is false. That means this will always be false if this is no solution. Okay, whatever values you plug in, the left side will always be greater than the right side, but we want the equation less than, so it'll never work out. So it's no solution. What happens if we get something like this? Remember, the variables need to cancel out in order to have a special case. So what happens if we get 0 is greater than -5? Is that true? Yes. That is always true. 0 will always be greater than -5, so that we have infinitely many solutions. Okay, once again, this is when the variables cancel out, then we have to look at special cases. Just because the variables cancel out does not mean that you did something incorrect. You know, later I want to talk about on a graph, why does that look like that? Why is it no solution? Why is it infinitely many solutions? But today, we're just gonna work on the procedural portion of it. We're gonna practice the algebraic fundamental skills on that. So let's take a couple examples to see what happens. So your first example, let's say we get 2x is less than 2 times x minus 4. Alright, multi-step. Multi-step means you have variables on both sides, you have lots of distributed property, lots of steps going on. That's our goal, is to get the variable still by itself. So how are we going to start this? I'm going to distribute that. Remember, you're sharing it, you're passing it along. So you have 2x, you multiply, and then 2 times 4 is -8. So you have 2x there still. I want to move this 2x here to isolate the variable because this is already by itself. There's no point moving this over here. So we're going to subtract 2x here, subtract 2x there. What happens? What do we notice? They both cancel out, so you have 0 is less than -8. Is that true? Is 0 less than -8? No. So this is false, so it's no solution. What this means is you will never find an answer that will make this equation true. Try it. Plug in any values for x, for both x's, so 0, 0, 1, 1, 2, 2. You will not find a value that where the left side will be less than the right side. Think about it. If you want to talk about conceptual portion, think about it. If I have 2x is less than 2x minus 8, well, they both share this 2x, correct? So they kind of go away. They're worth the same values. But then what is happening to this right side? The right side is being subtracted 8. So if we're subtracting something to this, what happens if they have the same value? Well, this right side will always be smaller because we're subtracting it. Versus here, we're not subtracting. So what happens, the scale, it drops like this. That means this side's going to be a lot less than this side. But then my inequalities, we're trying to figure out an inequality where it's going to be less than. The left side's going to be smaller than. It's never going to happen. So in this case, we find out once the variables cancel out, mathematically, algebraically, it'll never be a solution, so it's no solution. Okay? Let's try one more. Same, let's just switch it up. We'll keep it very similar. Less than 2 times x plus 3. Okay, same concept, we distribute. So you have 2x is less than 2x plus 6. If you look at this conceptually, what happens? These two are the same values. They're worth the same because they're 2x. But what's happening to this right side? We're adding something to it. We're adding 6 more to it. What happens when you add 6 more to it? It tips the scale. So this side here, which side should be greater? Should this side be greater or should this side be greater? This side. This side should be greater because we're adding more to it. And this inequality states that this side is going to be less than that side. So that's always going to be true. This side will always be less than this because this side is going to be adding something more to it. So it's going to tip the scale. So algebraically, we show that by subtracting 2x on both sides. My variables cancel out. That's what we want. So if the variables cancel out, we have to think to ourselves, special case. So we have to ask ourselves, is 0 less than 6? Yes. Always. So what's my answer? Infinitely many solutions. That means they all work. That means you can pick any value from negative infinity to positive infinity, all real values for x, and it'll always be true. Why? Because we're technically adding 6 here. Alright, so that concludes our lesson for solving multi-step inequalities. Our goal is to remember the special cases. There's 2 of them. What were they? When is it no solution? Is when they'll never equal each other. It'll never be true. And it'll be infinitely many solutions if your answer is true. But remember, you cannot have any variables, so when the variables cancel out. Alright, so that concludes our lesson. Let's try our 3 examples, our beginner, intermediate, and advanced level. Good job. Are you guys ready to try these problems? So let's try our beginner problem. 10x minus 3 is less than 4x plus 6. Multi-step, x is on both sides. Get it to one side. I don't care which side you want to move it to. I'll try to avoid negatives because there's extra rules when we multiply, divide by negative. But whichever way, you will get the same answer. So try your best. 30 seconds to a minute and go. Okay. I'm going to try this problem. I'm going to move my x to the left side. So I'm going to subtract 4x. So what I'm doing is I want to avoid negatives. If I move the 10x there, I get negative. So I don't want that. So you have 6x minus 3 less than 6. It's a little bit easier than having negatives there. So then what happens? X by itself, no. What's my first step? Add 3 to both sides. That cancels out. So you have 6x less than 9. Is x still by itself? Not yet. We're going to divide by 6. That cancels out. So you have x is less than 9 over 6. We could simplify it to what? 3 over 2. So that's my answer. Let's graph it. 3 over 2 is here. 1.5. Open dot or closed dot? Open, because it's not equal to. X is less than, what are values less than 1.5 or 3 has? 0. 0 is on this side. So I'm going to go here. So anything to the left side is a solution. So this is a multi-step problem. Lots of steps, variables on both sides. Alright, check your answers. Let's try our intermediate problem. Alright, step 2, our intermediate problem. So if I gave you this problem, x over negative 6 plus 7 is greater than 9. Get x by itself. Remember our rules. About 30 seconds to a minute. Go. Alright. What's my first step? You have, is x by itself? No. You have a divide by negative 6 and you have a plus 7. Our goal is to move it to the other side using inverse operations. My first step is what? How do you get rid of that plus 7? Good. We're going to subtract 7 on both sides. So you have x over negative 6 is greater than what? 2. Good. Is x by itself? No. How do you get rid of a divide by negative 6? You're going to multiply by negative 6 on both sides. Why do we do that? The reason why we do the opposite is because top and bottom will cancel out. So negative 6 divided by negative 6 cancels out. But what do? We multiply by what? A negative answer. So what do we have to do to the sign? Good. We got to switch it. So instead of greater than, it's going to be less than, and we get negative 12. So that's my answer here. So make sure you swap the signs. Always have them in your head. And then if I graph this, if I have negative 12, open dot or close dot, open dot, good. Less than negative 12, I want values smaller than that. So that's my answer there. All right, so once again, check your answers. Places where a lot of kids will make a mistake is swapping the signs. Some kids might make a mistake when you divide by negative 6, what they need to do. Kids don't like fractions, you just do the opposite. So if you're dividing, you multiply, you divide. All right, good job. Our last problem, our advanced problem. Let's take a look. If you have 2 times 3x plus 1 is less than or equal to 3 times 2x minus 4. About a minute. Try this problem. Try your best. See what happens. Your hint. There might be a special case going on. Try your best. 30 seconds a minute. Go. All right. First step, distribute both. I'm going to distribute there, distribute there. So you have what? 2 times 3x is 6x. 2 times 1 is what? 2. What about on this right side? 3 times 2x is what? 6x. 3 times negative 4 is negative 12. As you can tell already, you have 6x, 6x. So that means they're worth the same. What happens to this side though? We're going to add 2. And what do we do here? We're going to subtract 12. So which side is actually bigger? If you're going to add here but subtract there, but they have the same values with my x's, this side will be what? Bigger. So automatically, if I'm saying I want this side to be less than that, it'll never be true. It'll never be true because this side will always have to be greater than. But we're trying to find values of x that will make this true. There won't be. But let's show it algebraically. Let's do what we normally do. Let's move our x's to one side. Let's move all our numbers to the other side. I'm just going to subtract 6x here. That cancels. You technically have 2 is less than negative 12. You could technically stop here. We don't have to move all my numbers if my variables cancel out. But take a look here. Is 2 less than equal to negative 12? Will that ever be true? No, never. So there's no solutions. You can't even graph it on a number line because there are no answers that makes it true. But once we get rid of the 6x, you can kind of see visually what I'm talking about. Right? Here we're adding 2. Here we're subtracting 12. So it should look like this. Right? The balance shifts and now we have, this should be a lot more, it should be greater. There should be a bigger number on the left side than the right side. But we want to somehow make it less than. That is never going to be true. We're never going to be able to find that. So this one's no solution. If it was the other way around, if I switch this problem the other way, then it'd be infinitely many solutions. So that concludes our lesson. Hopefully this video has helped you. Please subscribe to my channel, turn on notifications, and let's get ready for some more videos.